In this lecture, we'll discuss about calorimetry principle. Okay, principle of calorimetry. So, when hot body is mixed with cold,
Yes, sir.
when a hot body is mixed with cold, the heat lost by the hot body is equal to the heat supplied or lost by the heat gained by the cold. Okay,
Yes, sir.
this is an important principle. Suppose if you mix ice and water or
Yes,
water,
sir.
so now in ice and water, water will lose the heat.
Yes, sir.
Ice will gain the heat. The amount of
Okay.
heat lost by water is equal to amount of heat gained by ice.
Yes, sir.
So the heat supplied by the hot body should be equal to heat gained by the cold body. This is
Cold. Yes, sir.
that we will use to solve all the problems. Okay.
Yes, sir.
The system will be isolated so that no heat is lost to the surroundings.
Yes, sir.
Calorimeter. Okay, the question. Calorimeter is a device used to measure this concept.
Yes,
Because
sir.
it's like an isolated material where you'll keep two or three objects mixed, and heat lost by the hot bodies should be equal to the heat gained by the cold bodies. Using that
Yes,
principle,
sir.
derive the results. Okay,
Yes, sir.
um, because the heat will not be going outside
Oh, yes, sir.
the system. Now, question you can write: 30 gram of ice minus 10 degrees centigrade is kept in a insulated container. Find the amount of heat required to heat increase its temperature by 60 degrees. Okay,
Yes, sir.
may I explain this question? Okay,
Yes, sir.
slowly I will increase the level so that you will understand this concept, and two or three questions are given in the previous years medical exams and mains exams also based on this concept. Okay, I'll explain you.
Yes, sir.
30 gram of ice.
Sir, it will be from -10 to
uh, okay, you know this concept,
-10 to 0 degrees.
you
Ah,
already know.
yes, sir. I know, sir. Like from 10th, I have studied, sir.
Oh, 10th, you're CBSE, you belong to CBSE.
No, sir. ICIC.
Oh, awesome. Then I wait. 30 gram of ice. Thank you. Yes. 30 gram of ice at minus 10 degrees centigrade is kept in an insulated container. Find the amount of heat required to increase its temperature to 60 degrees. What will happen is, I told you already regarding the heat curve in
Yes,
the
sir.
lecture. First, minus 10 degrees to where it will go?
0 degrees, sir.
0 degrees ice. That is melting
Yes.
point.
0 degree ice to 0 degree water.
Here there is no phase change will not occur here from here to here.
Yes, sir.
When
M is delta T.
entire ice reaches 0 degrees, then melting happens.
Yes, sir.
That is the concept we need to have clarity on. When then ice slowly get converted into what?
Water. 0 degree of water.
So minus 10 to 0 degrees. Then 0 degrees to what will happen in the heating curve? 0 degrees water it will convert to
0 degree of water.
0 degrees of water. That is good. Then what will happen? Water with temperature 60 degrees.
Yes, from 60 degrees.
That's the concept here. So energy should
Yes.
be supplied to it for this stage, and this stage. Got it?
Yes, sir.
This stage is like temperature rise kind of case. That where we will use ms delta theta, right? Formula.
Yes, sir.
This stage is like phase transformation phase. There we will use ml.
Yes, sir.
This is again temperature.
EMS delta T.
Now the formula is stage 1, stage 2, stage 3. Stage 1, what is the heat required is Q should be equal to 30 into the ice is hot, half, right?
Yes, sir.
Half calorie. Half calorie. What is the unit? Half gram per degree Celsius. Half calorie per gram per degree Celsius. So
Yes,
half
sir. Half calorie per
delta theta is how much? 10 degrees, right? That is
10
minus
degrees.
of minus 10. That is 10. Finally 0. Initial is minus 10. So 0 minus
Yes,
of
sir.
minus 10. 10 plus 30 into L. Second stage. L is how much? Ice melt. Ice to water. What is the latent heat of
1 calorie per gram centigrade, sir.
so 180 calories.
Oh, that is, sorry, Latin heat. 80 calories.
80 calories, right?
Yes,
80 calories per gram. So
yes,
80
sir.
calories per gram. So 30 into 80
Yes,
plus
sir.
from 0 degrees to what is it? 60 degrees. So again a
Yes, sir.
temperature range. So ms delta theta 30 into S for water is 1.
Yes, sir.
Delta theta
MS
is 60 minus 0, right?
Yes, sir.
This is 2
15,
150
150
plus
plus 240, 2400, sir.
2400 plus
Plus 1800.
add what will happen? 1800 2400 150.
150. Yes, sir. 2 to 4, 4350.
Question: 20 gram of water at 20 degrees Celsius is mixing with 10 gram of water at 80 degrees Celsius.
Yes.
What is the final? Can you try solving this question? I'll
Yes,
explain.
sir.
Here, if you observe this question, 20 gram of water at 20 degrees Celsius, there is
Yes, sir.
one substance which is water,
Yes, sir.
one substance which is water, and other substance is also water, right?
Yes, sir.
At different temperatures. So there's no two phases changes should happen here. No phase
Yes,
change
sir.
is required.
Yes,
This
sir.
water temperature will rise and this water temperature will,
Fine.
because this will supply the heat and this will gain the heat.
Yes, sir.
One is 20, another is 80. 20 will rise and 80 will decrease. So
Yes,
there
sir.
will be one temperature at which they will meet.
Yes, sir.
This heat gained by this 20 gram water should be equal to heat lost by this water, right?
Yes, sir.
Then if you go with the principle, so ms delta theta 20 into s is 1 into delta theta is T minus 20 should be equal to heat lost by this water, that is 10 into s is 1 into 80 minus T. Got it?
Yes, sir.
You can ask me, sir, it is going from 80 to T, right? So you should
Yes, sir.
take T minus 80, isn't it?
Same I had doubt, sir.
No, no, no. T minus 80 is actually heat gained. We'll get.
T minus 80 is heat gained, sir.
So minus you need to apply for heat loss. That's nothing but bigger temperature minus smaller temperature. Positive value will be there.
Okay, okay. Okay, sir.
Bigger
Okay.
minus smaller. Positive value will be there.
Yes, sir.
That means directly I'm equating the heat lost is equal to heat gain. I'm not
Yes, sir.
saying heat lost
Understood,
as
sir.
minus and heat gained as plus.
Yes, sir.
If I represent like that, here you need to write as the T minus 80, final minus initial.
Yes, sir.
Then it is lost. Negative value will come, right?
Yes, sir. Yes, sir.
Then it is lost. Heat lost. Negative is heat lost. Here positive is heat gained.
Yes, sir.
Whatever this is lost is, this is gained by here.
Yes, sir.
That will be equal to 0. Then again you will get this equation. Are you understanding?
Yes, sir.
How I solved it? Just bigger minus,
Understood, sir.
bigger minus smaller. But this is actually lost positive value, gained positive value. Similar to, suppose if I give you 10 rupees to you, I lost 10 rupees and you gained 10 rupees.
Yes, sir.
It is minus from my side plus from your side.
Yes, sir.
But instead that I am just representing my last money, that is 10 rupees, is equal to your gained money, that is 10 rupees. Both positive only I am representing.
Yes, sir.
Got it? Why did I write 80 minus T?
Yes, sir. Got it, sir.
Don't get confused with this. 20, 10, 0, 0 cancel. 2T minus 40 is equal to 80 minus this 3T is equal to 120 implies T is equal to 40 degrees Celsius.
40 degrees.
Okay.
Yes, sir.
Shall I go ahead?
Yes, sir.
10 gram ice at minus 10 degrees Celsius is 30 gram of water at 80 degrees Celsius. They both are mixed. Find the state of mixture. And what is the temperature? If this, what is the temperature at that point? Point is, ice here. There's water here. Water will actually lose heat. Uh, ice will actually gain heat.
Yes, sir.
So if you want to, first let me check. This will lose heat. This will gain heat.
Yes, sir.
If it has to rise, it has to give. Second part. If it has to fall, it has to give. So I say, see, first suppose ice getting converted into water first.
Yes, sir.
Will it get converted or not? We need to check, right?
Yes, sir.
Is the required what is the ice has to get converted into water? Will the water has required energy there?
I couldn't get, sir.
Now ice should convert into first 0 degrees ice first, right?
Yes, sir.
Then 0 to 100 degrees water, right? No. 0 to 0 degrees water.
Yes, sir.
Then 0 degrees water to again some heat will come.
80
It cannot
degrees.
go to steam. It cannot go to steam because this water is present. This is
Yes,
only
sir.
water. There is no possibility of it going to steam.
Yes, sir.
It might go to some temperature of water. That is the maximum it can go because it is It should be less than 80 because it is falling rate continuously. This also.
Sir, but in first problem we solved like this, no, sir? From -10 to 0, 0 to 0, then 0 to 80.
First problem I told, simply asking you to find out the energy required.
Yes, sir.
This problem, the question is not energy required.
Okay, okay, okay.
But energy should be given by this water.
Yes, sir.
Can the water have this energy or not? That you need to find out.
Yes, sir.
What I'm trying to find out is just I'm trying to check this entire water coming to 0 degrees because that is the maximum it can give. I'm thinking.
Yes, sir.
Let me check first in case. Then I'll go to the other step coming to ice also.
Yes, sir.
First I'll check this. What is a 30 into 1 into 80 minus 0, right?
Yes, sir.
It is 2400 calories is available now. But is suppose if it is getting converted into ice also or zyada energy available hoga.
Yes, sir.
First I'm seeing here. Here for suppose ice getting converted from -10 to 0. So what is the energy required here? 0 -10 to 0. That is 10 into half into 10 degrees. Right?
Yes, sir.
Is it 50 calories?
Yes, sir. 50 calories.
Okay. Now is this 2400 higher, right? Isn't it?
Yes, sir. Yes, sir.
Awesome. Awesome. Then will it further go? Because available whatever the your tanker is heat energy supplied is higher than this 50, this 2400 is
Yes, sir.
higher than 50 calories.
Yes, sir.
So it indicates this ice further can go and get converted itself into water.
No, sir. The water should lose some energy.
Why? Water lost 50 calories only. Still 2350 is available. If entire water is getting converted into coming to 0 degrees, right?
Oh, yes, sir. Okay, okay, okay. From
So
0 to
initially
8.
you don't see first required. You need to see. Suppose you see you are
Uh,
senior student, right? Example, just I'm
yes,
trying.
sir.
It's out of the box maybe. So
Uh,
the first, what is more important? What is the required? You need to see first.
yes, sir.
Available, then you will see.
Yes, sir.
You need physics, so you will check for physics availability.
Yes, sir.
You need to get taught electrostatics entire topic. You will check for
Yes, sir.
faculty. So first, then you will check whether it is available or not.
Yes, sir.
So then you will slowly learn from here whether available. Okay, my expansion will happen first, or your requirement is important. Tell me.
Yes.
Requirement
My requirement.
is important. Your ability to take. Now
Yes, sir.
50 and plus further it can go. It can lose further. So it has a
Yes,
capacity
sir.
to lose. Again 10 into 10 into L, right? Because phase
Yes,
change.
sir. 1 into.
Awesome. Awesome. Why? Because now entire combined is how much?
850.
If it has to come to the same 0 degrees, I'm not saying it did come to 0, but if it is coming to 0 degrees Celsius, how much energy it will lose here?
2400.
2400 calories. But what is required here for bringing from ice to water at 0 degrees Celsius?
850.
This is more than this, right?
Yes, sir.
That means this is entirely this. It will not come to 0 degrees. Did you get this point?
Yes, sir.
Now it will come to it. Now 850 calories has come to one state, right? Initially.
Yes, sir. Yes, sir.
Now what I'll tell, it is 0 degrees water. Simply this is 80 degrees water, right?
Yes, sir.
Not 80 degrees water. Okay, this is this 0 degrees water will go to some temperature. So this 80 degrees water will actually come to some temperature. Okay,
Yes, sir.
got it?
Yes, sir.
Now what I'll do is the amount of energy required is 850. Okay,
Yes, sir.
plus M. how much is mass 10 into S is how much? 1, right?
Yes, sir.
E minus 0. Do you accept this or not?
Yes, sir.
Amount energy, this 850 it will take first. Are you getting this, Was?
Yes, sir. Getting, sir.
Plus, it will go to some temperature, right? Because still the further availability is there, possibility.
Yes, sir.
It means 10 into 1 into T minus 0. Because 0 degrees it's starting and it will go to some temperature T.
Yes, sir.
That is equal to, it's 10 grams, right? That's why. So
Okay.
here mass is how much? 30 grams.
30, sir.
So 30 into, it is not changing any phases, just it is falling temperature.
Yes, sir.
So 30 into 1 into how much? 80 minus T. Are you getting this?
Yes, sir. Yes, sir.
First case, what did he do? 80 minus 0 I wrote. Just try to check whether how much it can give actually to see that number.
Yes, sir.
That number is far, far, far higher than this 850, right?
Yes, sir.
Then I just, now I understood it will not come to 0. It will come to some temperature T. Here, this will also go to some temperature T. At the time, the mixer will be completely state of water. Okay, this question got solved for me.
Yes, sir.
Simply by this calculation, we can say simply that it will be completely water, right?
Yes, sir.
If temperature is not asked, your tick mark is water. That's it.
Yes, sir.
If temperature is asked, this is the procedure. Okay.
Sir, it can be even steam also, like it can get 100 degrees Celsius also.
No, it cannot. Why? Because your water is completely falling. This water has to go to steam. So that much water should be there so that it can go to steam. No, nothing is there in steam only.
I didn't get it, sir.
Okay. How to relay this example? Okay. Your friend has 550 marks.
Yes, sir.
You have 350 or 400 marks, per suppose. He is trying to help you. Okay.
Yes, sir.
Now his knowledge is only 550. You don't assume that he can get more marks. Just.
Oh, okay, okay, sir.
So now he can bring you to 550. That's it, right? Maximum.
Yes, sir. Yes, sir.
So can he suddenly because you are actually taking help from him. You are not helping him, provided you are not helping him.
Understood, sir. Now I understood.
Now how he can go to 650 marks? It's not possible.
It's not possible. Understood,
He
sir.
is in a giving state. How his temperature will rise?
Yes, sir. So the maximum in this 30 gram it can spend is only 2,400. It
No,
can't spend more than that.
it can spend, but in which case is here a lot of ice is there.
Uh,
So at that time, this further loses energy and gets converted into ice. Suppose
Got it, sir.
if this 10 gram is at minus 150 degrees ice,
Yes, sir.
in that, I mean, otherwise 60 grams of ice is at minus 150 degrees kind of thing. So slowly it will capture all the energy from this water.
Yes, sir.
Then this water gets converted into ice. And entire ice will reach to a certain temperature and it will stay stable there.
Okay, okay, okay. Understood.
Entirely that system will get one constant temperature and it will become stable.
Yes, sir. Understood.
Got it?
Yes, sir.
Good questions you asked. Now did you understand now why did I think it will be water?
Yes. Now because that quantity is less, no, sir. Like for water, the specificity is less and the energy is also given less and the weight and when compared to ice, it is also less, no, sir. So
Okay.
it can't go to that big state of ice.
So it cannot go because if it loses, it is losing 2,300, but it requires only 850. That means
Yes, sir.
this will come first. Till what?
Yes, yes, sir.
850.
Understood.
Okay. So then 850 plus 10T is equal to 2,400 minus 33. Then 40T is equal to 2,400 minus 850. Add 50 and finally we can subtract 50. 2,400 minus 900 means how much?
Uh,
15, right?
450, sir, I think.
1500, 1450. Because what did I do is you add 50 to it, later on will subtract.
Yes.
Add 50 to it, 900. 2400 minus 24 minus 9 is 15. You did not get the calculation?
I got it, sir. Understood, sir.
So 1450, so T is equal to 1450 by 40.
Yes, sir.
So 4 3s are 12, 25, 4 6 are 24.1, 4 2s are 8, 2 again, 4 5. So did I solve? Wait, check.
Yes, sir.
4 3s are 12, 25, 4 6 are 24. Then 1 is there. So I did some calculation mistake maybe. Is it 16?
What, sir?
Check the calculation. Is it correct?
Yes, sir. It's correct.
So 36.25 degrees Celsius is the answer.
Yes, sir.
But this is coming to be 1550, right?
Ah, yes, sir. 1550.
Or if this extra is subtracted, I need to add that 50
Yes, sir. Yes, sir.
extra. So I need to add later on. 900 if it is 1400, 1500 plus 50 I need to do.
Yes.
Got it?
Should be five. Yes, sir. 5,000.
By 40. 0 0 cancel. 4 3 is 12. Oh, 35. That is 4 4 8 is 32. 3. That is 4 7 is 28. 2. And that is 4 5 is 20. 38.75 degrees will be that. Now you understood this? Now the
Yes, sir.
state is water, entire mixture is in water, and its temperature will be 38.75. Now everything got the same temperature. Now there is no losing of heat, there is no gaining of heat.
Yes, sir.
It will remain in that state.
Yes, sir.
Got it?
Yes, sir. Got it.
So then question. Question. Did it teach you right that length is proportional to latent heat. That slope is
Yes, sir. True call, sir.
okay. Then another question. Bullet of mass 50 gram is moving with the speed of 200 meter per second. Let's say wooden block of mass 2 kg and loses entire kinetic energy and 50% of it is lost in the form of heat to the wooden block. Find the increment in temperature of the wooden block. Got it?
Yes, sir.
In,
Sir, can you scroll up?
in efficiencies, it loses all the energy, but only 50% is get used lost in the form of heat. Okay.
Yes, sir.
Then specific heat of block is 2 calorie per gram degree Celsius. Okay.
Yes, sir.
Solve the problem. Now, actually, the concept here is this is another quality, and this question concept is asked in 2018-19 on this concept, 18 or 19, I don't remember the year, but on this concept itself. What is that concept is? Conversion of mechanical energy into heat energy.
Yes, sir.
I told you mechanical equivalent of heat, right?
Yes, sir.
For converting for 1 calorie of heat to be gained, you need to do a mechanical equivalent of 4.2 joules of work. You would have seen this in my lecture. No, you don't remember? Do you remember or not? I lost you. Do you remember this or not? Nivas? The mechanical equivalent of heat. Now, it's a mechanical equivalent of heat. Is nothing but I taught you in the first class. It is 1 calorie of heat. To generate 1 calorie of heat, 4.2 joules of mechanical work should be done, if you would have remembered, isn't it? Isn't it?
Yes, sir.
Now, nothing but here, bullet will have kinetic energy. That is actually mechanical energy. That gets converted into heat energy. Well, but only 50% of it gets converted. So whatever
Yes, sir.
bullet can give, that much energy into half you need to do. 50% means half of it, right?
Yes, sir.
That should be put it into the amount of heat gained by the block. Block gained, heat gained is what? Ms delta theta, right?
Yes, sir.
Then can you find out the temperature of the block now? Rise in temperature, right?
Yes, sir. We can find out.
Then you
Yes,
can
sir.
calculate.
Rising temperature.
Equation is half into M is how much? 50 grams. 50 grams is 0.050, right? Kg. Half into mass into
Yes, sir.
E square. That is 200 meters per second. 200 square is equal to. This is kinetic energy. Kinetic energy 50
Yes, sir.
converted into. That means again into half.
Yes, sir.
That is equal to mass into mass of the wooden block is 2. Specific heat is 2 calorie per gram into ms delta theta. That is delta theta. But one thing you need to remember, this is in joules.
Yes, sir.
Energy is in. But we know this
Yes,
is
sir.
calories.
Yes, sir.
You need to get converted into calories into 4.2 joules. So in the right side, 2 into, that is 2 kg into S, that is 2 calories into 4.2 joules
Yes, sir.
into delta theta. If you solve, you will be able to get delta theta easily. You can find this answer.
Sir, can you send this photograph of this sum, sir? Like
I,
what you solved in the screen?
I'll try to send it. Did you understand the
Yes,
equation?
sir. Yes, sir. I understood the equation.
Okay, thank you then.
Thank you, sir.